Hello, I'm doing this so we can review all the concepts and go a little deeper than we did in the morning. It's because I want you to understand where everything comes from. So in the first question, they said, work out 4 to the negative 2. So 4 to the power of a negative 2. Here we're asked to write it as a fraction, to write this 4 to the power of negative 2 as a fraction. How are we going to do that? We have always seen something like this, 4 to the power of 2, and that number 2 is telling us to multiply this base or to write that number 4 twice, 2 times, not 4 times 2, ever, no. It's just rewriting this, writing that number 4 2 times. So 1, 2, there you go. And that will be equal to 16. All right, but that 2 is positive. So how do we do it when we have a negative power? We are going to take a look at something. That number 16 here, or this number 16, is also divided by a number 1, invisible number 1. It's never there because any number divided by 1 is the same number. Any number divided by 1 gives you the same number. You see? Now, how is it possible to have a negative power? All you have to do is to switch these two. How are we supposed to switch that? Oh, guess what? 4 to the power of negative 2 can also be written as 1, which is going to be this number 1 here, over 4 to the power of 2. But 4 to the power of 2 is also 16. We just saw it. 4 to the power of 2 is 16, and that is something we can work with. So it would be 1 over 16. Is that we can switch them and know that whenever we have a negative there, we have to put a 1 on top of this. Or let's see, if I had a number 1 and then I had a 5 to the power of negative 2, what are we going to do? I'm going to switch them. We said we were going to switch them, right? So if I switch them, it means that I'm going to have a 5 to the positive 2, because if I switch them, I'm also changing the sign. You see, it is positive in the bottom, it is negative on top. It is negative in the bottom, so it has to be positive on top. On top of what? Well, that number 1 goes down. So I can say that 5 to the power of 2 is also 5 times 5. I repeat the same base as many times as the power or index is telling me, which is also 25. In this case, 5 to the power of 2 is 25 over 1. But guess what? That number 1 disappears. We never write a number 1 in the bottom. So that would be just 25. You see what the difference is? When you have a 5 to the negative 2, yes, that number 5 goes in the bottom with a positive 2. And that number 1 goes on top. So it would be 1 over 25. Instead, if you had a 1 over 5 to the negative 2, yes, you have to switch them. So it would be 5 to the power of 2 over 1. So it would just be 25. You see how it works? We switch all the time. Now, how do we solve this? That's how we solve a fraction. So what's the answer? This is the answer, 1 over 16. So this is the answer of how to write this as a fraction. Then write your answer in decimals to 2 significant figures. So they were saying decimals. I forgot to write it here. So we have to show it as a decimal with 2 significant figures. How do we turn a fraction into decimals? What we have to do is, remember the video we saw before, previously for this lesson? The number on top goes inside. The number on top goes inside. The number on top is also the numerator. So it goes inside of this symbol that is going to tell us that we have to divide. The number in the bottom goes outside. So that's what we're going to do. And then we're going to start asking that number, asking these two numbers. How many times can 16 go into 1 from left to right? So how many times can 16 go into 1? 16 is bigger than 1, or is greater than 1, right? So it can't really go into 1. So 0 times. I have to write my answer on top. Then what else can I do? I don't have any number on the right side of that number 1. So I'm going to put a decimal point there, and I'm going to add a 0. That 0, I'll take it down. You see? That's how I ask for permission. Then I'm going to ask again. How many times can 16 go into 10? Nothing there. I don't hear an answer. So this point is allowing me to put as many zeros below as I need. So I'm going to put another 0 here, okay? Now I'm going to ask, how many times can 16 go into 100? You know what we have to do? We are going to solve our multiplication tables. And let's see, 16, right? I'm going to multiply these times. 1, 2, 3, 4, 5. What am I looking for? I'm looking for an answer that is below 100, but is close to 100. Now, how do we know how many times can 16 go into 100? I have to work with my tables, and I go as fast as I can, or knowing the table of 1, 2, 3, 4, 5, 6, 7, I stop there. Why did I stop here? Because I know 96 is below 100. Actually, I didn't have to do this one, but I wanted to show you what happens. If you say that 16 is going into 100 6 times, you will get a 96, right? So yes, 16 can go into 100 6 times and you get a number 96. Why didn't I choose the number 7? Why didn't I choose a number 7? Because it will go above 100. It's 112. So I'll start saying, okay, this is not the answer. I stop here and this is the number I take. I need to know how many times I go into 100. So it's 6. And the answer to that is 96. How do we solve this? I forgot how to subtract. Okay, 100 minus 96. I have a 0 there. So I have to look for the following number that can let me turn this 0 into a 10. The number on my left is 0 again. So I have to ask for permission to that number 1, and I'll go here. That number 1 is allowing me to make this number a 10. And I can say 10 minus 6 is 4. Guess what? Since this is generous, since the number on top is generous, and this one is also generous, it turned this 0 into a 9. All the zeros that are between this number and this are going to become 9. So our next operation is going to be 9 minus 9 is 0. I already took one number from this one, so I have nothing left. Nothing left, 0. So my answer is 4. We don't write the 0 in front unless it's with a decimal point. Since it's not with a decimal, I leave it as a 4. That's how I subtract. So this is my answer for this part. Next, they said to 2 significant figures. We have to know what significant figures are. So I wanted to give you a review on that. How do we recognize significant figures then? We are going to have different positions of numbers, and we need to be able to identify if they count or not. First, we have leading zeros. Leading zeros, as the name tells you, are the ones that are leading the rest. So this is one of them, this is another one, and this is another one. Those are leading zeros. Non-zero digits, that's the number 2. Non-zero digits are all the numbers that are not 0, just as the name is telling you. So 5, 8, 3, in this case, in all these numbers. Then you have an in-between 0. This 0 is between 5 and 8. That's what we call an in-between 0. And last but not least, we have the trailing zeros, all the zeros at the right side of your number. How do we know which one has, if our number has 2 significant figures, 3, 4, 5, 6? Let's look at some examples here. So examples with of significant figures. We have the first number. All of them are non-zeros. So the amount of significant figures is going to be all the numbers that I count. 1, 2, 3, 4, 5, 6. So yes, 6 significant figures. Then we have leading zeros. Leading zeros don't count. We have all these numbers that are leading zeros. So our actual amount of significant figures for this number is 3. 1, 2, 3. Then we have 48,000. 48,000 can also be written as 0.0, right? Because any number that we can have, or in decimal form, that is 0.0, we have to count all these amounts. It's 48,000. So the amount of, or the number of significant figures is the amount of numbers that we have there. 1, 2, 3, 4, 5. 5 significant figures. Then, this is the same example as the first one. All numbers are non-zeros. All numbers are non-zero. So I'm going to have 4 significant figures. Last but not least, I have a 1.000 or 00040. How many significant figures am I going to have there? I have to count all of them. You know why? Because I need to count all the zeros in between, 1, 2, 3. The leading number is not 0, so I counted 2. Then a number that is not 0, so I counted 2. And then the trailing 0, the one on the right side, the trailing 0 counts. The trailing 0 counts. So I'm going to have 6 significant figures here. And that's how we find 6 significant figures. Now, let's go back to the exercise. They said find 2 significant figures with these decimals. We have 2 leading zeros, but only 1 6. How many significant figures do we have here? You guessed right, it's only 1. I know, we have to keep working. I know, we have to keep working. Because we didn't have enough time, I didn't complete this exercise before, but yes, now I'm doing it, okay? So remember, I had put this point before, and that point allowed me to put as many zeros on here as I needed. My next question is going to be, can 16 go into 4? No, the answer is no. I put another 0. This point here is allowing me to put as many zeros as I need. And that 0 is going down. Guess what? That 0 is going down. So I have to put a 40 there. 40. I have to ask again, can 16 go into 40? Maybe I have to look for a number that is below 40, but it's close to 40. So I'm going to go here to check my numbers on the table. And I see that number 3, it's 48. But guess what? Number 2 is below 40. This goes above 40. So I can't use a 3 and 48. But when I multiply it times 2, I get 32, which is below 40, and I can use this, okay? So all I have to do now is subtract this. Again, I'm taking 1 from this number 4. This becomes 10. 10 minus 2 is 8, and since I asked for one number from that 4, this became 3. Then 3 minus 3 is 0. So I stop there. I don't put the 0 in front of the 8. And that is my answer in 2 significant figures.